Hey everybody, welcome to the webinar. I'm one of your hosts today, Mac Rasmussen, and joining me, my partner in crime, Cole McLeod.
Hey everybody.
Cole. So we're going to talk to you today about product variation and automating it with SolidWorks tools and DriveWorks. And so we're going to wait just a couple seconds here. It looks like we've still got people that are joining and signing in, logging into the webinar. So just give us just a second and we'll let everybody join. And maybe while we're waiting, just a quick housekeeping thing. This is a webinar, so all of you kind of by force are going to be muted, even if you have a functioning headset and microphone like we all do in these COVID times. But we want to interact with you and we want to answer your questions. So you'll notice in your webinar interface, there's a questions area. So don't feel like you got to wait till the end to ask your questions. As Cole and I are going through material and showing you stuff, if you have a question, just type it in there and we'll keep an eye on that and we'll do our best to answer your questions, as they come in on the fly. And if it's something we just can't get to because of time constraints, we'll get back to you after the webinar. So this webinar is being recorded. So one of the questions we get most commonly is, hey, can I get a recording of that? And the answer is yes, you can. So if you just reply to the email address that sent you the link to the invite, you can get a link to the recording. So, all right, it looks like our logins have kind of stabilized. So welcome everybody. We're going to go ahead and get started. Again, my name is Mac Rasmussen, one of the tech people here at GoEngineer, and joining me is Cole McLeod, and we're going to walk you through some product variations, model complexity. Okay, so in our talk today, we're going to take a really common, it's a common problem, but a really simple product and go through iterations and discuss and show you the impact on complexity that really simple design changes can have. All right, so our business objectives is pretty straightforward. So we have this simple product. We've got this table, comes in a range of sizes. So you can see the height, the width, and the depth choices. So it's even inch increments, not an infinite number of choices. Customers can't pick any wild size they want. We offer it in a range of sizes. So 24 choices for height, 36 for width, and 12 choices for depth. Okay. And so we'll kind of cover about how we've been doing it with SolidWorks up to this point, and then we'll try to automate that a little bit. Okay, so first we're going to take a look at parametrics. This is kind of how we're doing it now currently. And this is review for a lot of you, but parametrics just means our dimensions are actually parameters in the model. So we can click and drag on them, or we can type in a unique value, some number, and our models update and resize, right? Very straightforward. That's what parametrics means. And so what we've been doing is we've had these 3D parametric models, and so as we got orders in, we kind of had a master model or like a master folder of our assembly that we just do a pack and go on, right? And copy everything to a new folder under a new order number, change the dimensions and all that kind of stuff, right? So the downside of doing it that way is we've got lots of duplicate files, never a good thing, not good practice. Lots of wasted disk space because of all the duplicate files. And then, pack and go always doesn't do a perfect job of breaking references and, other little niggling issues that you can have with pack and go. So we kind of like to do things better, more efficiently. And that's where configurations come in. Okay, so let's take a look at configurations really quick. Configurations allow us to pre-build variation into our models, right? So if we offer something in standard sizes, we can kind of configure those as SolidWorks configurations, right? So in this example, we can set up our own standard lengths very easily using the power of configs. So let's switch back to SolidWorks and take a look. So, here's those same dimensions, right? If I right click on it and say configure dimension, then each row that I create here, and I'm just going to give this a really sort of easy to understand name, 24-inch width, and then click in the little field, and the value for the dimension in this configuration should be 24. And I'll just continue this process, 25-inch width, right? So again, the first column there, the configuration name, is actually, in real life and best practice, these would be unique part numbers that would represent, the various dimensions that we're changing in the config. In the old days, this would be called a charted drawing back in the old days of paper drawings, okay? So let's do one last one here. Let's do 27-inch width, and we're good. And then we'll say apply and okay. And then we'll switch over to the configs tab in SolidWorks, and you can see we've got all of our pre-built sizes now, right? So as I click on these, you'll see the changes happen. So very, very simple, very easy. Looks good, right? Now, how does this work with assemblies? Well, anytime you take a configured part and you use it in an assembly or a configured assembly, like a subassembly, you get to pick which configuration is in use, right? So I dragged and dropped a frame in there. Now I can pick which configuration is being displayed in the assembly, okay? And if I control drag and copy, now I can pick this instance in the assembly and have it represent a different configuration, right? So 24 on the left, 27 on the right, okay? Really, really common. All right, same thing with drawings. Every time you make a drawing with a view that's got a configured part or assembly, we'll just take the isometric view here and drag that onto the screen. We'll pick the 24-inch config and then duplicate that same view. Let me just break the alignment here, right click, alignment, break, and we'll drag that one over. And again, change the configuration that's being displayed. So very similar functionality in assemblies and in drawings, right? So when you have multiple configurations, you get to pick which one is in use. So let's pop back over to the PowerPoint here. The downside is it's pretty manual, right? You saw me have to right click on that dimension, create the configurations. And if we wanted to vary things more than just a simple one dimension, it gets a little tedious. So that's where design tables come in, okay? So this is great. Design tables let us leverage the power of Excel, right? So notice the color of these dimensions. Notice how they're black still. And we've got all these configurations already created from our previous steps. So if I say insert table, design table, notice that was the Excel icon there. I'll just take all the defaults and hit go. It's smart enough to realize and pick up the variants we've already got in the model and make a new, row. Every row is a configuration in the design table. And then to add other parameters, I just highlight the dimension and double click on it like that. And now that one's added to the as a column, right? Every column is a variable. And then I can use all the cool stuff in Excel, like, copy and paste, right? So I can use incremental drag. So if I highlight a couple cells and grab that bottom corner, it'll automatically increment that variable. So, really leveraging the power of Excel, okay? And then you'll notice dimensions that are controlled, see how they're that bright pink and magenta? Dimensions that are controlled by a design table are actually a different color. So now let's edit that table in a new window. And that'll bring up Excel kind of in its own window rather than being embedded, inside the SolidWorks graphics area. This gives you a little bit better visibility, easier to read. And I can hide some of these rows and don't delete them because some of those rows are necessary. And then you can do some cool things in Excel just to help you visualize things like, let's go to the text alignment here and I'll kind of put these at a little bit of an angle to make that easier to read. That looks good. And then these rows I don't need to see. I'm not going to delete them. Don't delete stuff because some of them are necessary. But again, look at the incremental drag. So I'm just going to incremental drag this, create a whole bunch of new configs, and then same thing with these dimensions, right? Incremental drag to change the width, and then copy paste. If I have a repeating pattern, I can copy paste or incremental drag all these cool tools that'll let me create these variants really, really quickly, okay? So I just hit save on the Excel spreadsheet and close and watch what SOLIDWORKS says. So watch up on my screen here. It comes up and says, hey, I've created all these configurations for you, and presto, here they are, right? So you can see we've got all these configs. So that's pretty cool. Now I'm gonna pop over here. Let's pop over to another example. And just as a quick, for instance, I've got a configured part here with a design table in it. So let's just look at this one real quick. And let's go and look at this table. So I'm going to edit this in its own window so it just pops up. And this is a classic application for design tables, right? So we've got a really simple model for a hydraulic cylinder. And it comes in a range of sizes, right? So that first row is all of our unique part numbers, and then a description, right, for each one. And then all the other columns are, either dimensional variables like length. So there's our longer stroke, bigger bore, different mounting features. There's a trunnion mount, right? So what you're seeing here is a feature. Not only can we change dimensions in their values, but we can turn features on and off. Tapped holes, like you see here, those trunnion mounts, changing dimensions. We can change colors. We can change materials. There's lots of cool things we can control through a design table. So really, really powerful. Okay. All right. So let's go back and take a look at our business objectives again, right? So we got the simple table. We want to offer it in a range of sizes, not an infinite, but just a pretty, I think, modest array of choices for height, width, and depth. But this is where we have to kind of measure the water before we dive into the deep end. Any of you listening in on the webinar that have done this before may realize how quickly your designs can get, how quickly the complexity can ratchet up based on this. So let's use a really simple example. We've got a parametric cube with 3 dimensions, height, width, and depth, right? We'll simplify it like that. And we're gonna offer this product with each of these variables having a value of 1 or 2. So the width could be 1 inch or 2 inch, the depth could be 1 inch or 2 inch, and the height could be 1 inch or 2 inch, right? So this is what the number of variants would be for that most simple example that you can think of, right? Each row would be a part number. And so we'd have this many variants for all the unique combinations of height, width, and depth, okay? So as you can see, each row is a unique size. In real life, each of these configurations would be a unique part number, but same idea. So what does the math look like? Well, for this kind of variation, every variable, so that would be the height, width, and depth, it becomes a term that's equal to the number of variations offered in that variable. So in other words, height would equal 2, width would equal 2, and depth would equal 2. And the number of variations would equal 2 times 2 times 2. So that equals 8, and there's our total number of variants, okay? So keep that formula in your head as we progress through this example, okay? Let's format the part number as follows. We're gonna have H and a number that represents the height value, W, and then the width value, D, and whatever number represents the depth value, right? So that's what a row in our design table is gonna look like. That's what our unique part numbers are gonna look like, okay? Also, one other tip for those of you thinking about doing stuff like this, or if in SOLIDWORKS you're thinking about doing equations or global variables or relations or anything like that, anytime you're gonna drive dimensions, don't leave them at their stock number like D1, where the arrow is pointing there. Give it an actual name that makes sense. So, 6 months from now when you come back to tweak your model, it'll make a lot more sense, right? And you do that by just selecting the dimension, in the graphics area, and then in the feature manager on the left, just go in and backspace over the D1 and type in height. Okay, and that'll be the new variable name for that dimension. All right, so we only have an hour webinar. And so because of our time constraints, I'm gonna walk through making a design table that only has 5 selections for each variable. So in other words, instead of the full range of length, width, and depth sizes, I'm just gonna do 5. And so that is going to give me 125 unique part numbers or unique configurations, okay? And so the total number of configurations we'd need for the real product is obviously way greater than that. So let's flip back over to SolidWorks. Let's take a look at this. So I'm going to start a little clock timer down here, and we're going to use a little Hollywood movie magic, because I'm not going to make you sit through and wait for me typing all of these numbers. And I'm going to use all the tricks in the book. I'm going to use copy and paste and incrementing drag and all kinds of fun stuff, but it's still going to be a lot of data entry. So let's get going here. All right, first thing I got to do is I'm going to have to add the new variable height into my spreadsheet. So again, you do that by making it visible. There it is. Double click on it. It'll add it to the spreadsheet. So let's go back to my spreadsheet. So there's my new variable. There we go. And then change its angle. And I'm going to fast forward here a little bit. But remember, that wall clock in the bottom is my real time. So now I'm changing my variable names. And then here's my desired nomenclature. And so I'm just going to move these columns around by doing a little cutting and pasting so that I've got height, width, and depth in the right order. And then I'm going to use some color coding as well, just to give me a visual cue. That looks good. All right, so now I'm going to copy and paste that whole block of 5. And you can see I'm keeping the height constant, changing the depth. Okay. And then I'm going back and for each block of 5 with the constant height, we're doing the change in depth, right? So I've got these repeating blocks of 5 where I have to go in and change the depth 5 times. And then when you see the little kind of dark green, that's where I've started a new range of heights. So we went from 12 to 13. And now we're on 14. And that's me just, there's not a lot for it, unfortunately, with this, even with all the tricks I can do in Excel. Because of the naming convention we've got, I can't use an incremental drag because it only increments the first range to H14. It's not smart enough to know to do the W28 or the depth or anything like that. So a lot of this is manual of me having to do this kind of typing, which is why I'm sparing you as much of this as possible and fast forwarding. But we're almost done here. All right. So we know we're going to have 125 variants, and I think I had 4 rows at the top of the spreadsheet there already. So we should be at like 129. So we're almost done. We'll do a couple more rows, second to the last, and here's the last. And that looks good. All right. So now when you hit OK and you close the spreadsheet, this is what you see in SolidWorks. The design table created the following configurations, right? And I'm saying, yes, I'd like to see them all. So you can see all the numbers here. There we go. Lots and lots, 125, right? And remember, I didn't even do all the width and depths and heights. So it's saying the spreadsheet didn't find some of these. So do you want me to take them out? And I'm saying yes. And you'll notice it did everything except for one of them, and that was the config in use. So I have to switch to a different config, then I can remove that one we don't need anymore, right? But you can see my clock. It's almost done. That's how long it took to create all those configurations, okay? So call it a half hour, roughly, to create those 125 configurations. All right, so in our real model, remember the formula we talked about, 24 times 36 times 12, because that's the number of options for height, width, and depth. We would have had over 10,000 unique configurations, right? I did 125, took me about a half hour. So say I could do 250 in an hour, with a coffee break. So doing over 10,000 would have taken me over 40 hours, right? That's a lot of work. The other considerations, things that you have to kind of think about, is when we add a lot of configurations to models, they get bigger. So you can see our frame model went from pretty tiny, 383 KB to close to 50 megs because we had those 125 configurations. Now, our other business requirements are our models have to be visible on the shop floor with eDrawings, which is our free viewer. So to do that, what we have to do is we have to go in and ensure, start my timer here again, we have to go in and make sure that all these configurations get rebuilt if there's a change in the model, and we're adding the display data mark and hitting save, okay? So you can see our save time on our frame used to be, like pretty much instantaneous, hit save, blink, and you're done, to now this is taking, quite a bit longer. And I'm going to, again, use a little movie magic and speed things up a little bit, spare you the sitting and waiting. But that running clock is the real wall clock time. So, this save, oh, not quite done. Start it again. There we go. Now we're done. This save took, 2.5 minutes, call it. So again, just a word of caution for those of you watching, if you have a standard part like a base plate or a gusset or something, and it comes in a huge range of sizes, it's tempting to do that as configurations and design tables, which you can do very quickly, as you saw, especially if there's a low number of variables. But you might have a really large part, and if that part gets used in your assemblies multiple times, you could be slowing yourself down. All right, so now what do design tables look like with assemblies, right? Because we're not just making, our product isn't just the frame, it's actually the frame and the tabletop, right? So here's my frame, right? And here's all my configurations, as you saw, blah, blah, blah. There they all are. Everything's good. Notice my dimensions are hot pink. That means they're controlled by the design table, so life is good. All right, let's close that and let's tile our view. Let's look at our tabletop. Now our tabletop doesn't change thickness, it only changes width and depth. So our design table here, much more straightforward, right? We're only gonna have 5 times 5, so 25 variables, not 125, right? So we're just, all the different combinations of width and depth. Again, only using 5 variations, not the real numbers, right? But so we've just got this repeating block of 5 for a total of 25. Okay, I've hid some of the rows at the top. But that's what that looks like, right? Now, let's look at the assembly. So here's what the design table in an assembly looks like. So all the same ranges of heights and widths and depths that we had in the frame, because that's really what kind of drives the assembly. Notice our tabletops will update as we pick them. What does this table look like, okay? So what we do with design tables with assemblies is the design tables with assemblies are, every row is a unique configuration or part number, and the columns are just the configuration names of the instances that are going in the assembly at that point. And so you can see we've got a repeating block of our tabletop for every height option, right? Because it's going to be the same, width and depth combinations for each height. It doesn't change with the height. So, adding the tabletop was pretty straightforward. Okay, so that's what that looks like. So you can see how a really simple product with not very wild options for size can get very complex very, very quickly. And remember, I just did a sample. I did 5 variations, not the real number. So I only had 125 configs, not over 10,000. But let's pop over to my partner in crime, Cole here. Cole, you on board with us?
Yep, I'm jumping in here.
And Cole's going to show us how to solve this, basically the same problem, but with DriveWorks.
All right. Mac, if you want to kill your webcam. And folks, I'm going to leave my cam off just to give you more real estate on the screen. And so DriveWorks, if you haven't heard of it, it's a partner product. It's a gold partner product that's been around since 2001. It only works with DriveWorks. Only works with SolidWorks. That's the integration that they're focused on and are going to remain focused on. They're not trying to work with any other CAD system. So really tight relationship with SolidWorks. So we're going to take a look at that 10,368 option combinations that Max spoke about, I'm going to set DriveWorks up to be able to generate only the models we need in less than 10 minutes. And what I mean by only the files we need is that when we get an order for a size, we're going to generate that data set at that time. That way we don't have to put labor costs into generating models and documents that we'll never use. We don't have to use up the disk space and the backup space for models and documents we'll never use. And this gives us the freedom to be able to do that. So the three major sections that we have to cover here is we have to capture our model data that we're going to control. And then we're going to create a really simple form to control those dimensions. And then we're going to build our rules into our model so that it properly updates to the sizes that we've spec'd. So let's start with the model data capture. Let's flip over to SolidWorks here. And I have my base assembly open. And I'm going to capture that into DriveWorks and then tell it that I want to control the frame and the wood top. And then I can open each part individually here and capture the dimensions that I want to control. So I'm going to double click and bring the dimensions up just like if I was going to manually edit. Highlight the dimension and then give it a name over here in the DriveWorks in the task pane at the right. So we'll get that depth and width dimension captured. And then we can bring up our height dimension and capture that. And then for our top, again, just our depth and width that we need to capture. There we go. So we have all those captured. That's our first portion. Now we just need to create our forms. So let's go into our form creation in our form designer here. In the DriveWorks interface now that we've toggled over to, we're going to put in a text box or a numeric text box, give it a name, and then we can put the min and max values that are allowed in that window. So we're going to say 60 for our maximum, and then our minimum was 24. We can go ahead and get that added in, and then we've got our depth that we're going to enter. Let's go ahead and do that. Get our mins and maxes. And then our height. Our mins and maxes for that, and we have our form set up. Now the next piece of this is going to be creating our model rules. And let's take a minute and take a little bit deeper look at how our model's set up, because I have a little more time to do this with the simplified method of setting this up in DriveWorks. If we look at our sketch for our frame, it's actually in the center line of our weldment profile. And that's a 2-inch square tube. So when we're entering a width for our tabletop, we're going to have to account on the frame for that offset. And the same goes for our leg height. We have a foot thickness, and then part of that profile offset again, and then the thickness of our tabletop that will have to be compensated for when we're calculating our leg length. And then we have our width and depth of our tabletop are straightforward, same as the value that gets entered on our form. So to compensate for those, what we're going to do here is in DriveWorks, we're going to create some variables with just some static values built into them that represent those values so that we can reuse them in different formulas and not have to keep entering the same number different places. So our profile offset is 1, and our foot thickness is 1/4 inch. That entered. And then our top thickness is 1 3/4 inches, so we'll get that set in here. There we go, 1 3/4 inches, and we have that set. So there's our 3 variables that we're going to reference now when we head down to our model rules. So we're going to pop in here, and the first thing I'm going to do is I'm going to build a file name rule, because instead of creating configurations, we're going to be creating new unique individual files. And we're going to base that file name, just like with the configurations, we're going to use significant part numbering here. So we're going to do our height by our width. And as you can see, as I'm building this formula, I'm not typing any code or anything. It's very WYSIWYG type interface, and I just put in the basic text that I want for the text portion, and then I can double click on the field value that I want to bring back from the form, and it puts in that text for me. And you can see my resulting rule then. Down at the bottom, there's the example. All right, now the bench top, I'm going to edit that rule just a little bit because I entered all 3 file names at the same time. I'm going to take the height off of that because, of course, the tabletop won't have a height rule. There we go. Now let's get into our dimensions. So our depth, we're going to go in and build this value, and this is going to be our depth value from the form. And then we need to subtract 2 times that profile offset, because this is the top of the frame where we saw that center line running down the middle of our profile. And the dimension we're entering on the form is actually outside dimensions of the entire table. So let's do that same thing for our width. Two times our profile offset. Go on that. And then our height. Now, up until now, you've seen me clicking around in this interface to select the values that I want. If you know the names of your fields, and when you get comfortable, you can certainly type like I'm doing here, and it'll narrow down to what values you have available. So I'm taking my height minus my profile offset, minus my foot thickness, minus my top thickness to get that proper height. And then our depth for our tabletop is just our depth value from our form. We can type that in. And again, you don't have to type the whole thing. You just partially type and then select the value. So you can get very quick at this input as time goes on. So that's our rules to control the sizes when these models generate. So let's go ahead and take a look at this. We have a height of 24 to 48, a width of 24 to 60, and depth of 24 to 36. We have all of those options available to us now. So we can go in here and come down to our Specification Explorer and bring up our form, and let's enter a new size that we want to create. So we're going to go 36 by 26 by 48. There we go. And then I'm going to release this. Now, in a normal production environment, what would happen here typically is this would go to a standalone machine that would take care of the model generation for us. But for this presentation, I've separated it out so that we can run it manually so we can see what's going to happen. So let's toggle over to SolidWorks. And now, when we generate these, what's going to happen is the base model is going to get opened up, file save as function on the files, and then resized. And that's all going to be automated by DriveWorks. So we'll go in here and select the manual generation. We'll grab our data set and say generate. And now you're going to see the files opening and being resized and updated to the size that we just chose. And there's a little model generation report showing us it was a complete success and there was no failures. And then we can go up and let's open up this assembly and have a little look. So there's our assembly in the new size, and we can measure from the top of the table to the bottom of the foot, And there we have the 48 inches that we spec'd. And then if we double check our sizes on the top, there's our 36 by 26 that we had spec'd out. So very quickly, we're able to generate new sizes now going forward. So we don't have to invest all that time up front to create those configurations or models. So taking a look at this, the setup took less than 10 minutes. A new assembly is created in much less than a minute. And now basically at our fingertips, we have the availability and ability to create all 10,368 unique configurations that we spoke about. And here we're going to go back to Mac because Mac has more coming down from our boss.
All right. Thanks, Cole. All right. Let me know when you can see my screen. All right. Yeah. So, that gives you a sense of how quick DriveWorks can create all that variation on demand compared to having to do it manually through SolidWorks. But, I put in the OT, burn the midnight oil and the candle at both ends and all the other jargon. And I got a table model, simple table model done with all the variations, right? So my model's huge, my save times are long, but I got her done. And the product has been a big success and making the company a lot of money and got a lot of attention from the boardroom. And so the boss just came down to engineering and said, hey, we want to add some options here. We know mechanics are starting to use these tables a lot for teardowns, so we want to offer a classic teardown top, a sheet metal top, instead of our classic wood top. And so every time there's a binary choice like this, like a wood top or a tabletop, we take all of our variants. So in my case, the 125, or in the real case, over 10,000, and now we've times it 2, right? So now we've got over 20,000, close to 21,000 variants. They also wanted to add an option to have casters, right? With and without casters, right? So we take that result, multiply it by 2, but wait, there's more. They want color sizes to match, or color ranges to match the common colors of mechanics toolboxes. So red, green, blue, black, white, yellow, and orange. So 7 different color options. And then because mechanics are starting to use this, and we didn't want people throwing like an engine block or a transmission on these teardown tables and having the frame bend, we're going to offer a standard frame and a heavy frame configuration, right? So another ×2. So what we're looking at here is our size variance, 24 × 36 × 12. And we know that's over 10,000. Then we take that ×2 for the wood top or the metal top, and then ×2 again for casters or no casters, and then take that result and multiply it by 7, and take that result, multiply it by 2. So standard frame versus heavy frame. So we've got over 500,000 variants with all these crazy options, right? So that's a lot of work. We talked about how long it was going to take me to create the full 10,000 variants, but I tell you what, even if I put in that massive amount of OT and work nights over the weekends and stuff like that, we're talking about over 2,000 of hours, 58 man weeks. There's just no way that using the classic configuration design table method, I'm going to be able to accommodate all that variation in SolidWorks. So let's pop back over to Cole and see if DriveWorks has some magic that can help us with that.
All right, thanks, Mac. Well, Mac spends the rest of his work here finishing up the the configuration method of creating our options available, we're going to go through here quick and get this built into DriveWorks. So we have our color choices we need to build in, an option for casters or no casters, standard and heavy duty, as well as teardown. So let's focus on the color choices first and getting those built in. What we do is we'll toggle over to SolidWorks here, and we're going to put in a special custom property on our frame that DriveWorks recognizes called DW color. So we'll go ahead and set that in here. And I'm just going to put a placeholder value of X in there for now. And we'll go ahead and say OK to that. And then I can pop over into the DriveWorks task pane and tell it that I want to control that property. All right, so now we have that property captured. We're going to toggle back to our main DriveWorks interface. And here, I'm going to create a table that stores my color options and then also the RGB value for that color, because that's what I need to use to drive that value. And I'm going to cheat and copy and paste these values in here. So we'll get those set in and we'll say OK to that. And that builds our table. Our next step is to, on our form, we need to add a field where we can choose the colors. So we'll use a drop down. And then with that drop down, we'll be able to reference the table. And you can see as I drag on the form here that it's kind of giving me some guidance as far as size and things like that. And we're creating an extremely basic form here. A little later on, I'll show you something, another end of the spectrum. But with the time we had, I wanted to focus on showing how things work. So I'm going to go in here and do a list all out of that table. And here's what's nice too, is there's little GUI interfaces to make formulas for all of the common rule types. So if you don't know the rule format, we can just use that GUI. And then I can come into test here, test my form. Yep, listing all my colors. Things are looking good. All right, so we have our drop down added. Next, let's head down and get our model rule built to drive that color on our frame. So we'll go into our frame. There's our color property as part of our model. And here we're going to do a lookup into that table. So again, if you don't know how to type a vertical lookup up, just grab the VLOOKUP command. It says, okay, what value am I looking up? Well, that's coming from my color value on my form in the color table, and I need to return the column of the RGB value. And I can hit finish, and look, it builds that formula for us. So a lot of helpful tools within DriveWorks here to help us with that functionality. So that gets us to where our color is built in. So let's head on to our next option. Our next option is our casters. So here, what we're going to do is I need to tell it I'm going to control that part file because I need to be able to eliminate it from the assembly when I don't want it. And in my features, I need to control at the assembly level the pattern feature and remove that from the model when there are no casters. So I'll capture that feature. Just another item we can control with DriveWorks is features. And we have that selected now. Now let's head over to the DriveWorks interface again, and we'll go to our form design. And we're going to put on a checkbox here to control our casters. And we'll bring that down. And I want to change what the user sees on this other than it just saying casters. I'm going to change that caption to say select for casters. So you can always edit these from the actual field name to have additional other items on them as well. We go, and then we'll head to our model rules, bring our caster model in, and then we have to build into the rule to take the casters out when we don't want them. So we're going to say that if the caster value is true, so we've selected the checkbox, then we want to unsuppress those parts so that they are part of our assembly. Otherwise, we're going to delete them out of our assembly. So there we go. The rule is that simple. And I'm going to copy that because I'm going to go over and paste that in to the assembly level feature. Now, I could use a variable, and that would be the best practice, is to reference a variable, but in the essence of time, I'm going to do the quick and dirty here and just get the rule in on the 2 items. So there, we're controlling that feature now. And now we have to edit our variable because we need to compensate for the height of the caster in our overall table height. So I just jump into my variable that I created earlier as a static value, and I use another if statement that accounts for when there's casters. We have a little bit more height to subtract from our overall height, about 6.89 inches there, total between the caster and the mounting foot that it gets welded to. So there we go. And we have that set now to compensate for that. Now back over to SolidWorks, because there's one more thing we have to capture, and we need to get the dimensions from our pattern because we used a pattern to place the rest of the casters. Now I did this separate because I wanted to show you that you're never stuck with this product. It's not like, oh no, I forgot this piece, I have to redo a whole section. You can come back in and make additions and changes at any time, quick and easy. Okay, so I'm just grabbing my width offset and depth offset here for my casters. There we go, we have those set. Now it's just a matter of toggling back over here to our DriveWorks interface, and I need to go into that assembly and drive those 2 dimensions, and it's going to work just like our dimensions did for our frame because those are centered on the frame. It's our width return minus 2 times that profile offset.
So Cole, as I'm watching you do this, one of the things that always impresses me about DriveWorks, any of you listening in that have ever tried to do this kind of stuff with macros or with the SolidWorks API are doing a lot of programming and manually writing code for if, then, and else loops. And notice how Cole's doing this. It's all like pull down, drag and drop. All his variables are in already all for him. He's just picking them out of a list. And any of you listening in that have tried to do this in other products that are similar from other CAD vendors probably appreciate the level of automation that Cole's showing you here.
Excellent, thanks, Mac. So moving forward, now we have all of the information built in to control our casters. And now we can jump ahead to the standard and heavy duty option. And what we're doing with this option is instead of a 2-inch square tube, we're going to use a 3-inch square tube. And since we built this as a weldment, we're able to leverage those weldment profiles and just switch our profile when we want to choose the heavy duty. So I capture my frame feature into my feature, but then there's additional items that I can capture because it's a weldment. And I'm going to grab my profile because I want to control the profile of that weldment as well. So now that we have that captured in SolidWorks, back over on the DriveWorks side, back over here on the DriveWorks side, I'm going to add another table here. So to make a choice between my 2 types, standard and heavy duty. Now the benefit of doing this as a table would be if another option ever came in, I just have to come and add a row. It takes me a couple of seconds and I'm off and on my way again onto other projects. So let's get our rating of heavy and standard in here. And then I'm going to cheat and copy and paste the profile names so that I don't mistype those because those are critical. There we go. We have the 2 library feature profile names in our table. And then we can go to our form design. And again, we'll just put a nice little drop down in here that references our table to choose which we're going to use. Get that sized and aligned. Try to keep some uniformity in our form. And again, this is just a lookup just like we did before, or a list all, I should say. And we're going to go into the bench, and from the rating column, we want everything in that column. And there we go. We have that set. Now let's head on over and get to our model rules. And we'll go into our frame, and there's that profile call out. And what I need to do is just give it the full file path so it knows what it's picking. So here's the path to my weldments. And then we'll just put the name on the back side of it with a lookup into our table. So I need to look up what was my bench rating. I need to look in my bench table and return my profile. And there's my formula. And you can see what that value turns out to be there. So that gets the standard and heavy duty taken care of. Now let's take care of our teardown top. We need to flip back over to SolidWorks here and get the tabletop opened up. And then we just need to quick capture dimensions just like we did before. So we bring the model into our data set, bring up the dimensions for the depth and width. And I'm just going to capture those real quick here. There's our depth. And then let's get our width. Go, and then I need a custom property for color. Last time I added it through the model. This time I'll add it directly through the DriveWorks interface. Again, just showing the user friendliness and robustness and flexibility of this interface. I can just add that right from there. It becomes part of my model. And then I can head back over here so that I can get that built into my system. So let's get a combo box for our benchtop type or a drop down here. This one we won't reference a table, we'll just put values into a list. Here we go, we can have a worktop or a teardown top. We've got that. And then we'll come into our variables and we're going to update our variable for our top thickness. Okay, so we need an 1/8 inch for when it's the sheet metal top as opposed to the 1 3/4 when it's not. So we've got that formula built. And then we'll come down to our model rules. And for our teardown top, we need to get that added in. Our depth, directly to our depth. Our width, directly to our width. There we go. Let's take a look at our frame now. I'm going to steal the formula for color. I can just copy that by building at the same time. And then our bench top, I need to tell it when to swap that file out. What it's going to do is a file replace. So when the bench top return is work, it's just going to give that worktop a file name and make the model, or it's going to replace it with the teardown top. If teardown is chosen, I'm going to copy this so I can paste it into the next section here. And we'll head into our teardown top. I'll paste that in quick. And then another if statement to tell it to use this top, depending on what's chosen. So if work is chosen, we're going to delete this top. If it's not, we'll give this top a file name. There we go. So that's how easy it is to set up a file replace. So now we have one final section to take care of here. Our model has gotten more complex. We need to update our file naming to include the rest of these options. So you can see one example result down there for no casters, with a heavy duty frame, with a workbench top, and the color was black. So I'm going to update my file names to include the rest of these options. So I'll start with the assembly. And as I'm typing this in, one takeaway is you don't have to use significant naming like we are here. That's what we chose for this example, but you can certainly use a part numbering system, a sequential part number. Those are totally acceptable, and you can build that into the process as well. All right, so getting in the caster option and getting in the frame option for standard or heavy duty, and then we just need to get in our top option here for the assembly. And then finally our color. There's our color. You can see a preview down there at the bottom is kind of cluttered looking, so I'm going to get the hyphens in like we had shown in the slide there leading into this. Pop that into our formula here real quick. Again, showing the flexibility that you can come back and edit and update really super simple anytime you need to or want to. And then I can copy this so that I can take this over to my frame. and put this onto the frame real quick. And then we can take out the top section because the frame doesn't need that included. There we go. Got it in there. And then the final thing is I want to include color as part of my teardown top file name because that will be powder coated the same color as the frame. Go and color on that. And we have all our file names updated to use our new file naming process. So here we are, all set, all options are added. We're ready for all these different option combinations. So let's go ahead and enter some values here. And I'm going to intentionally use our maximum sizes here. So I'm going to go to a width of 60, a depth of 36, and a height of 48. We'll use yellow as a color. Let's stick with heavy duty, get some casters in there. And then let's do a tear down top just to get all the new options selected. And we'll send that over. All right, now we're going to manually generate our models again. But pay a little attention this time because you're going to see a drawing pop up. We haven't talked about drawings yet, just due to time constraints, but we can definitely generate drawings. And you're going to see in this process that a drawing gets opened and properly scaled. That is why I chose those maximum numbers. So flipping over to SolidWorks, we're going to grab this and generate our data set that we just selected. Generating our frame and our top, getting it all put together in the assembly. And here's that drawing getting updated from the base to the new size, getting properly scaled. There it is. Again, due to time constraints, very basic drawing, but of course we can do more detail than that, do fully detailed parts, assemblies, all of those things. But I wanted to get a drawing in on this example. So there's our dimensions. We're doing the height as a text value just to show we can control that. And there is our final assembly with all of the options.
So Cole, DriveWorks can not only handle all the variation on the model side that we're throwing at it, but it can also produce basic complete documentation packages as well, right?
Absolutely. Word documents, Excel documents, XML, read and write to databases. So much that we can do that we didn't cover today, but we'd certainly be happy to sit down with anyone that has more interest and go through much more of the detail that's included. It would take me more than a day to show every single possible thing we could do. But we really focused on the design automation today.
Cool. Well, we got a couple of questions that came in. I think I've handled them all, but one, the question was something I knew you were going to talk about in a little bit, so I deferred. But one of our listeners wants to kind of, in a nutshell, if you can compare and contrast what you're showing to DriveWorks Express. And I said you were going to be talking about that in a little bit.
Yep, absolutely. Let me show just a couple more things here, wrap this up so I can show some comparison things, and then we can talk about that with a little more content behind it. So going back, our setup total time was roughly 25 minutes front to back, and we're ready for all 580,000 plus potential combinations. And again, the other important takeaway is we don't have to create everything ahead of time. We only create what we need when we need it, saving so much overhead, man-hour, disk space, time, all of those things. So let's talk a little bit more. We're going to talk about the packages in a second, but I talked about the basic form we made. I want to show the other end of the spectrum on the forms here as well. This is out at driveworkslive.com, so you could go check this project out yourself. But just to show some of the things that we can do with this semi-trailer is I can open this up. We get a full-on 3D preview here that we can rotate around, look at different areas of the product that we're speccing. As we change the size, it real-time updates. We can zoom to specific areas when we're making option selections, so we can make the user experience really user-friendly and really graphical. I can change my door type here. You can see that update. And just because I'm zooming in, I can still come back and rotate, look at the rest of the model. Okay. We'll step through the rest of the options here. We'll stick with standard foot. We'll go with the default taillight configuration, keep our steel sidebars, keep our aluminum rear bumper there. Choose our color. We can cycle through and see what we think we like. Look at the options, get an idea of what that might look like. Okay. Notice too, there's a price with this. There's line item pricing. We can take this to the whole configure price quote level, going well beyond what we've shown today. Here's a nice graphical. Let's put it in the real world. Maybe we want it to be nighttime. Let's make it nighttime. Get some stars in the sky, some shadows and lighting. So a lot that you can do with this. And I just wanted to point that out so we know we're not limited to just what we saw today. And there's tons of examples out there at that DriveWorksLive.com, different industries, different interfaces that work different ways. So definitely encourage you to go check that out if you're curious. And then getting back to the question that came in, yes, there are different levels of DriveWorks. DriveWorks Express has been in every seat of SolidWorks since 2008. It is a considerably more basic and stripped down tool than what you saw today. Some of the key things is inability to drive color, if I remember correct. It doesn't have the variables that I was able to leverage. So you have to do a lot more formula writing. It doesn't have tables like I use today to do lookups. That's just a couple of the things, but it is free and it is in every seat. It's intended for very basic, simple, individual design automation at your desk for the engineer. And then there's a mid-level package, DriveWorks Solo, intended for smaller implementations that don't need the real high end. And then what you saw today was one module of the DriveWorks Professional Suite. I was using the administrator module to do everything we did today. Develop the project, generate the models, all of that was done with that one module. And then the final forms that you saw through a website, that was using some additional modules of the DriveWorks Pro package. Again, a lot of detail in each of them. We'd be happy to sit down with you, talk about what your potential use would be, and help you narrow down which one could possibly work for you. So with that being said, if you want more information, here's key contact information for our DriveWorks lead, Mike Lamora. There's his email and his direct phone, and we'll leave that up for a little bit here. If anybody wants to scratch that down, we can take any more questions. If anybody has more questions, feel free to send those in. All right. I want to thank Mac for joining me today.
Yeah, it's been a pleasure talking to all of you guys. And just here's some of our contact information as well as Mike's if you have any other questions going forward. So I don't see any questions coming in live right now, Cole, unless we'll give them just a second in case somebody's typing furiously right now. But hopefully to the person that asked the question about DriveWorks Express versus the rest of the DriveWorks products, that answered your question. But feel free to reach out to us if you've got anything else. I guess the only other thing Cole and I want to mention about DriveWorks to make sure everybody knows is not only is it obviously fully integrated with SolidWorks, it's also fully integrated and works correctly with SolidWorks PDM and enables data reuse, right? So if you're generating a variation of a model that uses a standard configurable base plate and that particular size configuration was already created with a previous run, it's going to reuse that part, not like recreate another one of a similar size with a different number. So it's optimized for data reuse and works is designed to work with PDM sort of out of the box. Anything you want to add to that, Cole?
No, that's an excellent point that we do have that PDM integration, because that's typically very important. We're creating a lot of data at the click of a button, so we want to keep that organized. So yeah, there is full integration with SOLIDWORks PDM Professional built right into DriveWorks Pro.
Yeah, and specifically for that data reuse. That example that we showed you earlier where we were, using pack and go, right? You're just duplicating data over and over and over again with not really any regard of what's happened previously. And that's the big hang up that's solved by integrating with PDM and enabling data reuse. Looks like we got another question. Oh, nope, it was just somebody saying thanks. So, yep, thanks everybody. I don't see any other questions coming in, so we're gonna let you all go. Have a great afternoon, and thanks for joining us.